All right, you guys, I am very excited about this. We are doing the 2 Prop Z test today. So we have a competition here, Wendy's versus McDonald's. If you actually read through the wording here, it's quite interesting. There's apparently this company that goes to fast food restaurants each year. And what they do is they visit randomly selected times and they do a random sample of restaurants out of 10 major fast food chains in all 50 states. And what they do is they go and they order a modified item. Isn't that interesting? For example, a hamburger with no pickles, a side item, and a drink. And if any item was not received as ordered, or this is also interesting, if the restaurant failed to give the correct change or a straw and a napkin, the order was considered inaccurate. And we're trying to decide, is there convincing evidence? This is a huge keyword here. I'm actually going to highlight this. Is there convincing evidence? That tells us to do a test. I want that not to get confused with, let's look at the wording of these questions that we did yesterday. Construct an interval, like this one literally said do an interval. That's not a test, right? And then what did this one say? Estimate, when you see that keyword, that's an interval, and they told you the confidence level also. So keep in mind that this chapter is combining intervals and tests, and you have to be able to read the question and know what the heck to do, right? So the first two examples in the problem, or in this section, were confidence intervals. They gave you a confidence level, and they told you to estimate something. Here it says, is there convincing evidence? Ding, 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 you guys. That means do a ho and a ha. We're doing a test of a difference in the population proportions. This means we're doing a proportions question. You already know that because I titled it proportions. But look, if this were like the test and you didn't know if it was proportions or means, keyword right here, proportions, I'm going to highlight that also. Is there a difference between McDonald's and Wendy's? And it gave us some stats, 145 out of 159 were good at McDonald's, 139 out of 163. There's another P hat for Wendy's. Okay, let me highlight this really quick. It doesn't say, is there evidence that McDonald's is better? It doesn't say, is there evidence that Wendy's is better? The question literally says, is there a difference? Ding, 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 two-sided test. Okay, so read the wording really carefully of the question. Remember, that tells you how to do the ho and the ha. The ho is always an equation. I'll talk about that in a second when we get to it. The alternate, you read the words of the question to decide greater than, less than, or not equal. This literally just says difference. We are not like forced to believe one is better than the other or greater or less or anything like that. I'm also going to highlight my two different P hats that I have. So I have a P hat for McDonald's, which is 145 out of, what was that number, 159. And I also have a P hat Wendy's, and that was 139 out of 163. Those are my two different P hats, okay? I am going to erase those for a second because I wrote over this. But those are my two P hats, okay? What we're going to do, we're going to define the stuff. You guys know we have to define things. I have a P from McDonald's. That's the proportion of all the drive-through orders at McDonald's that were considered accurate, and accurate is defined up here. And I also have a PW, so I'm using M and W. You can feel free to use X's and Y's or A's and B's, but I think it makes sense to use M for McDonald's and W for Wendy's. And the populations are all of the McDonald's drive-through orders in the country, and all of the Wendy's drive-through orders in the country is the population for the second sample. Okay, we are doing a 2 Prop Z test because we are testing a claim. We are not estimating something. We are testing a claim, and I have two proportions, not one. Remember, I have a McDonald's proportion and I have a Wendy's proportion. So this is a 2 Prop Z test. Z always goes with proportions, always. We're going to check random, independent, and normal. And the thing that sucks about this chapter, it gets so boring, you guys, but you get a lot of points for doing all of this. We did take 2 random samples, so we're going to talk about both of them, okay? We have a random sample of 159 McDonald's and 163 Wendy's drive-through orders. Independent, is it reasonable to believe that there's more than 1,590 drive-through orders at McDonald's in a year in the country? Abso-frickin-lutely, okay? Is there more than 1,630 drive-through orders at Wendy's in a year in the country? Absolutely. So our 10% condition is fine. Okay. Normal condition. Here is something very new and very different. Okay. Alert, alert, alert. In your reading guide, here, if I were to teach you this in class, I would say, what did you write down for p hat combined in your reading guide? Or AKA the pooled p hat, or the pooled sample proportion. It's this thing right here. How do we find it? What do we do with it? When we are doing a test, notice that I did not have anything about this when we were doing an interval in the previous page. For a test for proportions, we do this thing called p hat combined. And it has to do with the way that we write the ho and the ha, which maybe I will show that here. There's my ho and my ha, and then I'll come back to the p hat combined. I assume for every single null hypothesis that there is no difference. We always assume that the two things that we're comparing are equal. Remember how the ho I've been talking to for an entire chapter always has an equal sign in it? So when we're comparing two things, we are assuming that those two things are equal. That is always how you write the null hypothesis, okay? And please note that it is also mathematically correct to write it this way, okay? For whatever reason, I like to have the 0 in there, but please know this is the exact same as that. And a lot more times you will see this like in textbooks and answer keys and AP sets and stuff, but they mean the same thing. Okay, and then remember up here we talked about how it's a two-sided test, so therefore I have my not equal sign here, and yes, that is the same as this. These are equal, they are the same thing, and I'm going to make a note to myself about being two-sided because I'm going to have to double the freaking p-value, and everybody always forgets that, right? Anyways, we have this p hat combined thing when we are assuming that the two p's that we have are equal, okay? So here's how we find p hat combined. It's actually on the formula sheet. Forgive me for flipping back and forth, but we are under the proportions area because we're doing a proportions problem. And look, p hat combined, it's right here. I take the two x's that I'm given, so like the two numbers of accurate orders over the two different n's, and I add them together, and that gives me my p hat combined. And look, it's going to go here and here when I calculate the standard error of the statistic. Okay, you have all this in the reading guide, but it's also on the formula sheet. Just wanted to show you that. So let me show you this p hat combined. I take the two numbers, the 145 of correct orders and the 139 of correct orders, and that's my numerator. And then I take my two n's. This is the sample size for McDonald's. This is the sample size for Wendy's, and that goes in the bottom, and that gives me a p hat combined right here. And what I do for the normal condition is I check the p hat combined with both of the sample sizes. Remember how the normal condition for proportions we do np and n1 minus p. Well, here's the problem. This is our p, and we have two different sample sizes. We have one from McDonald's and we have one from Wendy's. So here's what it's going to look like. Yeah, there's a lot of things, but look very carefully. I'm going to zoom in. I'm using the p hat combined that we just calculated. Notice how I'm using it 4 different times. And NM stands for the sample size at McDonald's. It's 159. Okay? And NW stands for the sample size at Wendy's. It's 163. And yeah, I'm using the p hat and the 1 minus p hat and the p hat and the 1 minus p hat. And yeah, those are the same because I'm using p hat combined. And I do this for a test, you guys, and the reason for that is because we are assuming both of the proportions to be equal. Let me go back to the formula sheet real quick. When the two proportions are equal, when we are assuming that, when we have a ho and two of the proportions are assumed to be equal, that is when we do this. Okay, you should have that in your reading guide. Just wanted to point that out. Anyways, we finally got done with all these freaking conditions. And yeah, once again, you get a lot of points for writing all this stuff. I know it kind of sucks, but don't be alarmed. That is how to get a 5 on this test that we're going to be taking here in May, okay? So anyways, the test statistic. Again, that's on the formula sheet. Do I need to go back to it? No, it's the same test statistic that we did in Chapter 9. In this case, it's a Z because it's a proportions problem. Think ahead 2 days, and this is going to be a T when we do a means problem, okay? Because we're not going to know the sigma of the population. But anyways, what is the statistic here? The statistic is the difference in the two p hats, okay? We have two different p hats here. One of them was 145 out of 159. Another one was 139 out of 163. And that is the difference between my two statistics. Okay, the parameter is the number from the hoe. It's 0. We are assuming no difference. So that is what the parameter is. The standard deviation of statistic, I'm going to take from the formula sheet, and I already kind of showed it to you. So what I'm going to do now is I'm just going to erase a little bit of this so we can see what this is going to look like. I'm plugging in just my numbers, or my variables first. This is my formula. I can zoom in a little bit here. The statistic is my p-hat from McDonald's minus my p-hat from Wendy's. It's the difference between my two samples that I took. The parameter is the number from the hoe, which is 0, the null hypothesis. Standard deviation of statistic, this formula is directly from the formula sheet under where it says P1 and P2 are assumed to be equal. And there's my p-hat combined. That goes right there. This goes right here also. This is in your formula sheet. The sample size from McDonald's goes here. The sample size from Wendy's goes here. So what does that look like? You're probably like, hurry up, Mrs. Johnson. You're going way too slow. This is super annoying. Sorry. Love you guys. Okay. Here's all my numbers plugged in. And yeah, I could type that into the formula sheet if I wanted to. Remember that the p-hat from McDonald's was the 145 out of 159. Read the question above. The 0 stays, the p-hat combined, this number is here, 1 minus p-hat is here, and those are my two sample sizes from McDonald's and Wendy's. That gives me, if we crunch this in the home screen, you get this, which is still kind of like hard to type in, which gives me a z-score of this, 1.644. Yes, I invite you to, as a group, work through 2 prop Z test in calculator. It just asks you, like, you literally just type in what's the first X, what's the second X, what's the sample size, blah, blah, blah. Very simple, but it'll give you this as a Z score. And then I'm going to do normal CDF in the calculator and get Z equal or greater than or equal to, I'm going to do the right tail first because this is a positive number. I'm going to shade to the right first and do the right tail. And then don't forget what everybody always forgets to do, which is double the p-value because this is a two-sided test. And that gives me about 0.1 as my p-value. Okay, so how did I come up with this number? I did normal CDF in the calculator, and I did 1.644 to the right forever with 0 and 1 as my mean and standard deviation, and that right tail is 0.05. But remember, since this is two-sided, we have to double this freaking p-value, okay? So be careful about that. I did draw an arrow from two-sided all the way to that to remind myself, and that gives me a p-value of 0.1. Okay, what does this p-value mean? Also, when you do 2 prop Z tests in the calculator, it gives you everything all at once. It gives you all your stats, your p-hat combined, your z-score, and your p-value. And if you choose the one that says not equal, remember, for the 2 prop Z test, it'll ask you greater than, less than, or not equal. It will double your p-value for you if you choose not equal. So it'll tell you the p-value is 0.1. Anyways, you guys, we are not given a significance level here. Remember that vocab word? Significance level, alpha. So what are we comparing this to? We're going to default to 0.05, which is what we almost always use unless otherwise told. So is that p-value too low? Is the p too low? No, it's not. So the hoe doesn't go. How do we write our conclusion again? Here we go. We say since the p-value is this number and that happens to be greater than alpha, it's not too low. We fail to reject the null. And then we just state the null. The null says no difference, you guys. When we fail to reject, we're not crossing out the hoe. We're actually just restating it. We have no difference between the accuracy of McDonald's and Wendy's, okay? And remember, when you don't reject the hoe, that means that you do not have enough evidence to throw the hoe in jail, okay? We do not have evidence of a significant difference between blah, 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 blah. You can fill in the rest, okay? Thank you for watching. I hope you really love that example, and I can't wait for you to try the next one as a group. Let me know what questions you have. Love you all.